When sizing a generator for an air conditioner, it is essential to use the lot rotor amps, abbreviated LRA, specification. This is because the LRA represents the maximum current draw that the compressor will require when it is starting. This occurs when the compressor is at a standstill and the motor is trying to overcome the inertia of the rotating parts. The starting surge is typically much higher than the running load amps, abbreviated RLA, because the motor needs to generate a high torque to accelerate the compressor. The generator must be able to provide enough power to handle the surge without overloading or causing the compressor to fail. Using the ampacity specification, calculated as RLA times 1.25 for sizing the generator is incorrect because it does not account for the starting surge. This could result in an undersized generator that cannot reliably start the compressor, potentially leading to damage or failure. Therefore, the appropriate generator size for a 15 kW to 30 kW single-phase 240 volts alternating current generator is based on the LRA specification of the air conditioning compressor. For example, for a compressor with an LRA of 129 amps, a 30 kW generator is recommended. This is calculated as 129 amps times 240 volts, which equals 30.96 kilowatts. There are additional considerations when sizing a generator. Firstly, other resistive and reactive loads in the home also need to be considered when determining the overall generator size. Secondly, the generator should have a surge capacity of 1.5 to 2 times the running load to handle the starting surge of the compressor. Finally, it is always best to consult with a qualified electrician or generator specialist to determine the specific generator size and requirements for the particular application. When selecting a generator, understand the difference between continuous and surge power ratings. The continuous power rating indicates the amount of power the generator can supply continuously, while the surge power rating indicates the maximum amount of power it can supply for a short period of time, typically to start motors. Air conditioning compressors require a significant amount of surge power to start, so it is important to choose a generator with a surge power rating that is high enough to handle the LRA of the compressor. The LRA value is typically found on the compressor's nameplate. However, if it is not available, a general rule of thumb is to multiply the RLA by a factor of 5 to 7 for single-phase motors. This will give you an estimated LRA value that you can use to size the generator. For example, if the RLA of the compressor is 20 amps, the estimated LRA would be between 100 and 140 amps. Always overestimate rather than underestimate the LRA to ensure that the generator is large enough to handle the starting surge. In addition to the LRA, you also need to consider the other loads that will be running on the generator at the same time. This includes lights, appliances, and other electrical devices. Add up the wattage of all of these loads to determine the total continuous power requirement. Then, add the LRA of the compressor to this value to determine the total surge power requirement. Choose a generator that has a continuous power rating that is greater than the total continuous power requirement and a surge power rating that is greater than the total surge power requirement. It is better to err on the side of caution and choose a generator that is slightly larger than you think you need. This will ensure that the generator is able to handle all of your electrical loads without overloading. Consider the fuel type when selecting a generator. Generators are typically powered by gasoline, propane, or natural gas. Gasoline generators are the most common type, but they are also the most expensive to operate. Propane generators are less expensive to operate than gasoline generators, but they require a propane tank to be installed. Natural gas generators are the least expensive to operate, but they require a natural gas line to be run to the generator. The choice of fuel type will depend on your individual needs and preferences. Consider the noise level of the generator. Generators can be quite noisy, so it is important to choose a generator that is as quiet as possible. Look for generators that have a noise rating of 70 decibels or less. These generators will be less disruptive to your neighbors. Consider the size and weight of the generator. Generators can be quite large and heavy, so it is important to choose a generator that is easy to move and store. Look for generators that have wheels and handles. These generators will be easier to transport. Consider the features of the generator. Generators come with a variety of features, such as electric start, automatic voltage regulation, and low oil shutdown. Electric start is a convenient feature that allows you to start the generator with the push of a button. Automatic voltage regulation helps to protect your appliances from voltage fluctuations. Low oil shutdown is a safety feature that shuts down the generator automatically if the oil level gets too low. Choose a generator that has the features that are important to you. It is important to maintain your generator properly. Follow the manufacturer's instructions for maintenance. Change the oil regularly and check the air filter. Store the generator in a dry place when it is not in use. By following these tips, you can choose the right generator for your needs and ensure that it provides reliable power for years to come. When starting an air conditioner, the compressor motor requires a high inrush of current to overcome the inertia of the stationary components. This inrush current, known as the locked rotor amps, is significantly higher than the current the motor draws once it is running at its rated speed, the running load amps. The duration of this inrush current is typically very short, lasting only a few seconds. However, the magnitude of the current can be several times higher than the RLA. A generator that is not sized to handle this inrush current may experience a voltage drop, which can cause the air conditioner to fail to start or can damage the generator itself. When sizing a generator for an air conditioner, it is crucial to consider the LRA, as it represents the peak current demand during startup. Ignoring the LRA and relying solely on the RLA can lead to an undersized generator that cannot handle the starting surge, resulting in potential damage to both the generator and the air conditioner. The LRA value is usually specified on the air conditioner's nameplate. It represents the current the motor draws when the rotor is locked or stationary. This is the highest current the motor will draw, and the generator must be able to supply this current without experiencing a significant voltage drop. To properly size a generator, first determine the LRA of the air conditioner compressor. This value can be found on the unit's nameplate. If the LRA is not available, you can estimate it by multiplying the RLA by a factor of 5 to 7. Next, calculate the generator's required surge capacity. This is the amount of power the generator must be able to supply for a short period of time to handle the air conditioner's starting surge. The surge capacity should be at least equal to the air conditioner's LRA multiplied by the voltage. Finally, select a generator that has a continuous power rating that is sufficient to handle the air conditioner's RLA and the other electrical loads in the home. The generator's surge capacity should be at least equal to the calculated surge capacity. In addition to the air conditioner's LRA and RLA, other factors can also affect the generator's performance, such as the altitude, temperature, and humidity. Higher altitudes can reduce the generator's power output, while high temperatures can increase the air conditioner's power consumption. To ensure optimal performance, it is important to consult with a qualified electrician or generator specialist to determine the specific generator size and requirements for your particular application. A generator specialist can assess your home's electrical load, taking into account all of the appliances and devices that will be running on the generator. They can also factor in the environmental conditions in your area to ensure that the generator is properly sized. Once you have selected a generator, it is important to install it properly. Follow the manufacturer's instructions carefully and consult with a qualified electrician to ensure that the installation is safe and compliant with all applicable electrical codes. Regular maintenance is also essential to keep your generator running smoothly. Follow the manufacturer's recommendations for oil changes, filter replacements, and other maintenance tasks. By properly sizing, installing, and maintaining your generator, you can ensure that it provides reliable power for your air conditioner and other electrical loads during power outages. When choosing a generator, consider the type of fuel it uses. Gasoline generators are the most common type, but they can be more expensive to operate than propane or natural gas generators. Propane generators are a good option if you have a propane tank on your property. Natural gas generators are the most convenient option if you have a natural gas line connected to your home. Also, consider the noise level of the generator. Some generators can be quite noisy, so it is important to choose a model that is relatively quiet, especially if you live in a residential area. Look for generators that have a noise rating of 70 decibels or less. It is important to choose a generator that is properly sized for your needs. An undersized generator will not be able to handle the starting surge of your air conditioner, while an oversized generator will be more expensive to purchase and operate. By carefully considering the LRA of your air conditioner and the other electrical loads in your home, you can select a generator that will provide reliable power during power outages. When dealing with electrical systems and generators, safety is paramount. Always consult with qualified professionals for installation, maintenance, and any troubleshooting. Ensure that all work complies with local electrical codes and regulations. Before starting any work on electrical equipment, always disconnect the power supply to prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves, when working with electrical components. Never overload a generator or electrical circuit. This can lead to overheating, damage, and fire hazards. Keep generators away from flammable materials and ensure proper ventilation to prevent carbon monoxide poisoning. Have a qualified electrician inspect your electrical system and generator regularly to identify and address any potential safety issues. Follow the manufacturer's instructions for operating and maintaining your generator. By adhering to these safety precautions, you can minimize the risk of accidents and ensure the safe and reliable operation of your electrical systems and generators.